Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation with constant coefficient. Uh, Please watch the video up to end. Example, solve x d cube y by dx cube plus 2 times d2y by dx square, and that is equals to x raised to 4. X square, sorry. If you observe the terms, d cube y by dx cube is multiplied by x only. Therefore, to convert it into Cauchy's form, we call that given equation as equation number 1. That equation 1 is x d cube y by dx cube plus 2 d2y by dx square is equal to x square with y as dependent, x as independent variable. Multiplying equation 1 by x square so that equation 1 is converted to a linear in Cauchy's form. Therefore, that equation 1 becomes x cube d cube y by dx cube plus 2x square d2y by dx square, and that is equal to x square into x square, it becomes x raised to 4. It is x cube d cube y by dx cube plus 2 times x square d2y by dx square is equals to x raised to 4. We call this equation number 2, and that equation 2 is in Cauchy's form. This is linear differential equation with variable coefficient. Then, to convert it into linear differential equation with constant variable, we put log x as z, new independent variable. X is equal to e raised to z. Capital D stands for d by dz. We have x into dy by dx as capital D operated on y. Similarly, we have x square into d2y by dx square as capital D minus 1 into y, x cube into d cube y by dx cube as d minus 1 into d minus 2 operated on y. Substituting all this in equation 2, equation 2 becomes, first term becomes x cube d cube y by dx cube as d minus 1 into d minus 2 operated on y minus 2 times plus 2 times second term as d minus 1 into y, and on the right hand side it is e raised to z, means x, and whole raised to 4. Simplifying it, d into that product of that two term becomes d square minus 3d plus 2 and second term is 2 times d square minus d, and taking y common from this 2 into y is equal to e raised to 4z. Simplifying it further, we have d cube minus 3d square plus 2d square plus 2d and minus 2d into y, bracket close, into y is equal to e raised to 4z. Plus 2d minus 2d get cancelled. We have d cube minus d square into y is equals to e raised to 4z. Equation number 3. That equation number 3 is a linear differential equation with a constant coefficient, y as a dependent and z as independent variable. Therefore, solving this linear differential equation by finding CF and PI. For CF, auxiliary equation is d cube minus d square is equals to 0, means taking d square common, we get d square in bracket d minus 1 equals to 0. Equating each terms to 0, we get d is equals to 0, 0 and d is equals to 1. First two roots are real and repeated, and last one is non-repeated. Therefore, CF becomes, it is C1 plus C2Z for repeated into e raised to 0Z and plus C3 e raised to Z, and we call this equation number 4th, CF. Then particular integral by inverse operator technique, 1 upon d cube minus d square, which we have to operate on e raised to 4Z. Then applying shortcut method, first shortcut method, we have to replace d by a. A is here 4, and therefore it is 1 upon 4 cube minus 4 square operated or into e raised to 4Z, and therefore simplifying it, we get 1 by 64 minus 16 into e raised to 4Z. Therefore, it is 1 by 48 into e raised to 4Z. We call this equation number next 5th as a PI. Then adding CF and PI to get the complete solution, we get complete solution for dependent variable y as CF plus PI. CF is C1 plus C2Z plus C3 into e raised to Z plus PI 1 by 48 e raised to 4Z. This is not the final solution. Final solution must be in terms of x and y. Therefore, once again replacing z by log x and e raised to z by x. Therefore, we get C1 plus C2 log x plus C3x plus 1 by 48 x raised to 4 as the required solution or required answer. Please like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe it, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.